Hallo alles, willkommen. Heute sprechen wir über DESY, Deutsches Elektronensynchrotron und Edward Witten. I'm in Hamburg, Germany to attend a lectures given by Witten on black hole thermodynamics, and it is rightfully named Invitation to Black Hole Thermodynamics. So, in a sense, it is just an invitation. So, it's a very short set of lectures and focuses on the basics of this newly emerging field that is not mainstream in many other universities. So, don't get scared to find out that your local university don't give these kind of lectures. Well, nobody does. And Witten isn't a usual physicist at a local university. He's a professor at Princeton Advanced Study, which is like they don't have an obligation to teach or grade or do anything actually. So, the reason I came all the way to Hamburg to meet Edward Witten is that I admired him. I mean, even from my high school years, I always wanted to meet with him. I own both copies of his books at Ankara, and he is just the father of the greatest achievements that human beings have ever conceived, which is string theory and theory. So he is the father of the second and third string revolutions, let's say. The third one is my imagination. I mean, it's not called a third, but holographic principle, if we count it, is the third string revolution. But definitely he's the father of the second one, in which he united all the other five string theories into one called M theory, that is like the famous 10-dimensional string theory that everyone knows. So, I mean, I arrived to Hamburg yesterday, so it's only been around 24 hours that I'm in Hamburg. So, I will just explain you my initial, I mean, observations about Edward Witten and DESY in general. So, DESY, if you don't know, is the, I think, second largest particle accelerator in Europe after CERN. But DESY is, as its name stands, is the national. So it's German. I mean, mainly German. I mean, so it's not a collaboration between different countries. And as far as I can see, everyone is like German speaking. So I don't think that there are many other internationals around here. DESY, I think, hosts some programs, not like this, not like schools or seminars, but summer internships or something like that. In that, I think they also focus mainly on German students, but I think they also accept some other internationals. And if you are interested if you are in Turkey, Cyprus, or any other related European country as well, you can try to attend it. I think it will give you and boost your academic portfolio. They have incredible facilities as far as I can see, and they are keep building things. I mean, half of the campus was just construction site, and it's just a bit hectic as far as I'm concerned, because in the morning I just wake up and I wanted to be there early to talk with Witten, but I mean, it's just so close, 5 minutes walk, but I got there like in 30 minutes, but because I wanted to take a tour, and I just got lost because of the construction sites. You don't exactly move linearly, so it's like I moved a lot at the outside, and when I try to return from another path, then that path was like conceived by another construction. So basically, it took a lot of time. It's like I couldn't return to my initial point, like the energy conservation law. Well, let's don't say energy conservation law. But I mean, you got my point. I just wanted to make a fancy physics analogy. Where it's like second law of thermodynamics, entropy always increases. The construction sites near DESY, as you move along, always increases. Let's say it like that. So, Edward Witten, let's talk about him. He is the genius of geniuses. This is not my quote, of course. This is a quote I think I seen in one of those magazines that explain scientific celebrities. Well, Witten is known by everyone. He is feared by many physicists because he is the smartest physicist often regarded. And I think it's true. I mean, even the professors here were scared of him. I mean, of course they won't admit it, but one professor tried to ask something about qubits, I think, and how they were there, and like, I think Witten, without like intending it, gave a bit shaky answer to him, and he was a bit disappointed, I think. And like he is like that because he's a very direct person. For example, if you ask something to me, or any other, I think, physicist, for example, what do you think about this? And he will be speculative in the about the 30% of the time because like he needs to give his or her ideas, right? But Witten is always like is perfectionist. Whatever comes out of his mind, he made sure that it is right. You can understand that because before he speaks, he takes a long time before answering it. And while answering it, he actually sometimes just stops and just says it like, no, no, I'm wrong, no, no, no. This should be like that. And then continues. It's like you see how his brain works in real time. So it's crazy when you think about it. And also another thing that I observed, for example, back in Ankara, for example, when I'm taking a quantum mechanics course, professor explains something, all right? For example, a state or something, or in engineering course, something. I mean, besides functional analysis course, which is a huge exception that I took from electrical engineering department at METÜ, but let's say a regular engineering course, for example, circuit theory 2, all right? So in circuit theory 2, for example, there's a rich mathematical structure that is not known by the professor, which is quite understandable because he's an engineer. But even in circuit theory, for example, I am begging for a more mathematical understanding by the professor to teach us because like it's like watching a Marvel movie, but you don't get the references. I mean, the whole point of watching the Avengers Endgame is the references. It's like think of it like that. You are attending the circuit. I mean, my whole point of my whole enjoyment is those references. You need to give me those references. And in quantum mechanics, for example, if the guy doesn't know functional analysis, don't teach the course. It's just as simple. Anyway, well, I'm sure that many other physicists will disagree with this point, and I know many. There's a very close physicist of mine who disagrees with this completely. A professor, a very respectable professor. But I mean, that's what you're gonna do. I mean, but at least you need to know functional analysis, okay? So Witten is completely opposite of that. He is the only theoretical physicist in history to win a Fields Medal. So he's like, Isaac Newton. Newton developed calculus as well as physics. And I think in yesterday or something, he gave an example of it as well. Because he said like, physics and mathematics goes hand in hand and gave the example of Newton. And I think he's the closest thing that we have to Newton in this century, at least till now. Because, I mean, while developing string theory, and I think he used morph and knots, morph theory and knot, something called knot, and also membranes, D-membranes, and stuff like that. So he revolutionized completely mathematical branches just for developing string theory. So the guy is genius. I mean, he's also developing mathematics because, string theory is such a rich theory that while developing it, physicists are seeing some similarities to advanced abstract mathematical concepts, and then they start to adopt it. But physics has reached the development of abstract mathematics. So let me explain quickly what I mean by that. What I mean is that for example, while Einstein was developing general theory of relativity, he didn't know quite well Riemannian geometry. And Riemannian geometry is developed by Riemann in Göttingen in 1850. So we are talking about the start of the 20th century. So, there's like a 70-year gap between two theories at the start of, between two theories, I mean mathematics and theoretical physics, let's say, in the beginning of the 20th century. And now, as you go along the path, quantum mechanics was developed and stuff. There was, of course, matrix, linear algebra was there, but functional analysis kind of developed with, and also inspiration comes from quantum mechanics as well. So it developed with the help of von Neumann and others. Functional analysis developed, but so around 1960s and 70s, I think the mathematics and physics gap has been shortened and shortened, and it's now going to the epsilon delta zero. You got the reference, right? So what I'm trying to say is that we are at the point in time that physics, especially physics of string theory, needs a very good mathematicians to create new mathematics for physics, because we are at that point of the threshold where development of physics has reached the development of mathematics. So that's why it's like Isaac Newton needs to develop calculus before explaining the bodily motions of heavenly bodies. And without physics being reached to mathematics, we can't actually develop a new mathematical concept. It's like a threshold, it's like a voltage value, like it's like capacitor. It develops to high point and then it just shortens. So it's like it's like GR is developed, so there's like a capacitor, your capacitor is fully charged, then it needs to discharge. So we are at that point, I think, in string theory, that we have a very good physical, I mean, we don't actually have the physical theory, so I'm sorry, I misconducted. But what I'm trying to say is that we have an intuition about physics. Well, I mean, calling it intuition as well is kind of wrong. Well, string theory, I think, I mean, some people might not even call it physics theory, you know. I think there are books by Lisa Randall called Trouble with Physics, and of course, I think Lee Smolin. But Lee Smolin is kind of a controversial figure because he is the founder of loop quantum gravity, one of the founders. So, loop quantum gravity people and string theory people are basically on the opposite sides. They are trying to do the same thing, but they believe in other things. Like it's like believing in the you. It's like, you know. I mean, I don't want to give this example, but I'm giving it anyway. It's like two people are believing in God, but they have different religions. But it's like that, you know. And the head of the cult of the string theory is Edward Witten. And the loop quantum gravity people are actually ambiguous, but Carlo Rovelli is a good figure for people in general public, because I mean he is the one who is writing the popular books. Edward Witten doesn't write the popular books, but he's so placed among the consciousness of people that everyone knows him, that how smart he is and how his ideas were developed. Like, I mean, even I think, you know, I'm gonna flex a bit because why not? Back home in Ankara, I have a signed copy of Sidney Coleman's book. Yes, I have. And Sidney Coleman once said that you need to accept Edward Witten because he's the smartest. Because he's the smartest man I know and smarter than me, and he's probably smarter than you. So accept him. So it's like so ridiculous, man. I mean, yeah, it's Sidney Coleman, okay? So it's not like I mean, it's not like your average guy. Sidney Coleman was the head of Harvard mathematics department, and he was like dubbed the modern Albert Einstein. He's that kind of a man, and he's telling that Edward Witten is smarter than me. So, I mean, like, come on, guys, and you know you can. So, I mean, I'm trying to give you the magnitude of the image that I think he deservedly created. So basically, what I was trying to explain to you is that Edward Witten is a mathematician, but he strongly believes that what he created, basically, not of course single-handedly, there's an army of string theorists around the world. I mean, fixating on a single person is always bad and unfair in physics, but Edward Witten, to be honest, let's be honest, he's the head of the cult. I mean, whatever he says, they follow it. And another fact is that if he weren't alive in the last 20 years, I don't think the string theorists will continue to study on the subject this passionately and this firm. I don't think that they would have gotten the fundings and everything, because most of them are working on this field because Witten says so. Witten believes in this theory so much that he believes that they should continue. But in reality, most physicists lack the mathematical intuition, rigor behind it, and also the talent, unfortunately. Because let's be honest, I mean, mathematical talent is a real deal. I mean, you know, especially in abstract. I mean, if someone is watching this who is not a theoretical physicist. By the way, don't watch this if you are not a theoretical physicist. This is very technical. I mean, I don't know. I mean, I don't know why would an average person watch this video. I mean, go and watch mathematical sociology. I mean, it makes more sense. It's more understandable. Anyway, so I'm gonna get in details. So what I'm trying to say is that Witten. I mean, so everyone can be a Witten, but you know, I mean, of course you can't be a Witten, but you need to have, anyways, you need to be a strong and very good mathematician. And among the people, I think it's like less than 5% of people studying mathematicians really are mathematicians. So how often a person can be both a very good mathematician as well as physicist? Because it's like when you want to do string theory, it's like trying to embark on a journey in Arctic. You know, you need to be expert on lots of fields, not just survival. You need to be also like, because if you are going to an Arctic, for example, you need to be good at, because you are going there for research, of course. So you need to be good at telecommunications, electronics, computation, so everything. I mean, in a way, it's like being a string theory is similar to that. I mean, because since you don't have a guidance as well, for an Arctic sailor, he has a guidance, right? He can look at his position using a satellite and stuff. But in string theory, in abstract mathematics, you are all alone. Your guidance, your satellite isn't fixated. It is your intuition, and that intuition changes from people to people. You might call it talent, you might call it even developed talent. I mean, you can develop your abilities and stuff. So let's not just name it talent, but it's not easy to become a very good mathematician. It takes years. I mean, you need to study things over and over again, abstract algebra over and over again. And for example, people like Witten's father, Louis Witten, was a great theoretical physicist back in Texas. So I mean, just so he's, of course, I mean, he started his university life as a journalist, which is a completely very interesting side video. But what I'm trying to say is that he belongs to family of academicians. So his father was studying general theory of relativity, and probably he taught Witten general theory of relativity. And that's actually another thing, because I don't think publicly it is available how it's Witten, for example, got interested in abstract mathematics and how he learned. I mean, which books he read. I mean, this is not known. And actually, I want to make a video about it. I mean, I wanted to ask to Witten about taking a video for him to explain the books he read and how his mathematics have developed over the years. I don't know if this exists. I mean, of course, there are bits of information that exist on the web, and I read them also, but I haven't seen a complete, for example, in chronological order how he learned. I mean, there's I think a, a, a small PDF on the web. I think at the Institute of Advanced Studies webpage where he wrote a what do they call it, when someone dies, professors wrote a memoriam for his or her death, to, for example, say that, oh, this guy did that, this guy did that, this guy helped me like that. And Witten wrote for Michael Atiyah. Michael Atiyah, by the way, a great mathematician from Britain, and he studied at Trinity College, Cambridge, then became a professor there, and he was a legendary figure in Morph theory and stuff. And as far as I know, this is how Witten got interested in those stuff. I think Witten at the time was trying. I think he did his PhD in Princeton, then go to Harvard, then return to Princeton. And at Princeton, I'm talking about Witten, by the way, at Princeton, he was trying to find a solution for quantum confinement problem, which is quite an interesting thing, because when I was in my first year at Matthew, I was talking this problem with Professor Altuğ, which is an interesting thing, because that also was captivated my mind back 3 years ago. So Witten was trying to solve this question, and then in his words, he said that, I mean, I couldn't solve it, so I needed to pick up. I mean, understand that Witten couldn't solve it. It's that hard to a question, and I think that question in itself, while people were trying to solve it, created lots of other huge fields and stuff. So by doing that, Witten, then I mean these parts are unknown, because Witten at the time of Princeton got invited by Atiyah at Cambridge. I mean, I hope that I'm not saying it wrong. Maybe Atiyah was in Oxford, but I think Atiyah was in Cambridge. Michael Atiyah. He was, I think, at Trinity, and there was another guy, MacDonald, I think. MacDonald was in Oxford, and they collaborated on a book called. I mean, they have collaborated on many papers, but I think they commutative algebra or something like that. The book's name was it, and by complete luck, I own a book owned by MacDonald, because my sister, I sent them a book about number theory by Andrew Wiles, great Andrew Wiles of École Normale Supérieure. I sent a book by him, by number theory, and by the way, I learned that book from Witten. There was like an old YouTube YouTube like video of Witten saying that I was reading this book and stuff, and then I got the book and it belonged to McDonald, and Atiyah worked together that influenced Witten. So there's a full circle here. Anyway, so Witten probably showed a mathematical prowess back in back in Princeton, then invited to Cambridge to meet Atiyah, and then Atiyah said that, for example, quantum field theory has these mathematical settings, like you can use more theory or stuff. I'm not sure, I think more theory Witten learned later, or Witten learned independently, then he, I think by himself, used more theory to his theories, but he learned a lot from Michael Atiyah, and Michael Atiyah had a great mathematical intuition and believed, he had some bold views. By bold views, he said that, for example, this theory arises in your physical intuition like this and stuff, and there were some that arose actually later. So Michael Atiyah had a huge influence on him, as far as I know. But what I'm wondering, for example, when he was 20, around my age, for example, when he was like late, let's say 28 even, how did he learn, for example? What did he do, for example, in mathematical stuff? And you will see, I wanted to interview him about it myself, but to be honest, it's a bit scary to talk to it. So I don't know if I'm gonna even ask him. But I talked to him, by the way. I asked him questions. Let's talk about my questions. At first, for example, in a normal setting, in a normal professor, I don't want to say normal professor. I've met with incredible professors, and to me, all of them, especially some, the one I'm working with also, Ulf Leonard, they are very special to me, and I respect them greatly. And I think, as a physicist, I think they're like the real physicist. Edward Witten is a mathematician, let's say, but I'm also I like mathematicians, of course. So, anyway, what I'm trying to say is that I need to interview Edward Witten, or someone needs to. I think these kind of ideas needs to be out there. For young physicists to learn about, even a mathematician, I think, because Witten, I don't think that his motivation is lost in mathematics as well, because he draws his inspiration from physics constantly. And for example, other than what was the guy's name? Hungarian guy. It's the strangest mathematician. Let me remember. It's coming to me. Wait a minute. I'm sorry. How come I've Paul Erdos, of course I remember. Paul Erdos was, for example, was legendary for having the greatest scientific stamina in history in mathematics. He, I think, published the most mathematical work ever. For example, if you look at his biography, Erdos was like a wanderer. He didn't even marry. He like went from one conference to another his whole life. He didn't even own the home. So it's crazy. And Witten, so Erdos is 101, yeah. So Witten is the case where he didn't lost his interest in mathematics or physics, because I think he gets inspiration from both fields. So Witten is an exception. He's like, really, when you think about the history of mathematics or physics, there are only few people like him. Let's say Hilbert even, but he's closer to mathematics than physics. Hilbert is closer to mathematics to physics. Witten is the other way around. So I think, for example, let's say, Newton maybe, because Newton, I think, is closer to mathematics than closer to physics than mathematics, but Einstein wasn't that great of a mathematician, so that's not why I'm saying. I don't think that Einstein ever made a mathematical discovery. Witten did. Witten is a mathematician. That's why I'm not giving the example of Einstein. By the way, I'm not saying that Witten is the greater physicist than Einstein. Of course he's not, by the way. So, in that sense, let's return what I talked with Witten. So, in the seminar, I asked him a couple of questions. I think at first I asked him about Kawanaga theory or something. To be honest, I'm not that aware of. There is a mathematical theory that is 150 years old that is being used in black hole thermodynamics. I just entered to, my computer architecture exam 2 days ago, so it's like entering to this stuff is very energizing and completely different at the time. And I just wanted to reflect on this for my personal preference anyway. So in a way, Witten was explaining the connections between the two, and my first question about like if this stuff was a conjecture, a mathematical conjecture, because I think 3 weeks or 4 weeks ago there was a friend of mine who studies at Utrecht, and we were discussing something about conjecture about information theory and the holographic principle in string theory. And Witten, as I told you, is the father of string theory. So maybe I thought that was connected to that, and he explained to me, my friend, that this is a conjecture, and I explained Witten about this, and he said that no, this is a known stuff, like 150 years old and stuff like and you can check it out. Our first interaction was this, and I don't know if I explained this to you, but he is to everyone that, for example, if he doesn't speculate at all. I explained this. He gives direct answers, okay? So if he doesn't know something, he says, I don't know, next question. If he knows something, he just explains that part, never speculates, and just moves on. If you ask him a question, he's like, an artificial intelligence. He gets your prompts, and he just creates a better prompt out of it. Like if your prompt doesn't make sense, he just analyzes it. This question should be like this, and he just answers that. So it's incredible to see him think again. So in a way, our first interaction was this, and then, of course, I picked a lot about his private talks in the breaks with professors, and professors are like afraid to talk to him. Students are also like no one. Yesterday he was eating cookies on his own. In the cafeteria he eats alone. I don't understand. He's the greatest physicist in the world. Come on, guys. We need to interact with him more. Maybe he should be also more. I don't know. What can you do? I haven't seen him act strange, I think, to anyone, by the way. So we need to break this stereotype of a theoretical physicist being awkward or strange. He's just a completely normal man who tries to help the people. Come on, guys. So, yes. My second interaction was I asked him about a term, because he was explaining Hawking-Gibbons term that is added to the action of general relativity. So you add this term to the Einstein-Hilbert action, and I asked him if this is unique. And I had some my doubts about my question, but he said, this is interesting question. Well, it is unique, but a better question is that if that is connected to if the bulk of Einstein's equations are not affected if I add additional terms. So Hawking-Gibbons term is unique, but if you add additional terms to the metric, which is the bulk of Einstein's equations, would the equations hold again? And the answer is yes, they hold. So you can add additional terms, but under specific conditions. And also, I think this arises in ADS-CFT holography and stuff, and I think he was very excited because of it. I could see in his eyes while explaining it. And another thing, because it is unique, but under Driehaus conditions, under Neumann conditions, I think you can come up with other terms. This is not important. This is very technical stuff. And my other interaction is with him, This is now let's come to my obsession about entropy. So, because we were calculating the entropy of a black hole in ADS-CFT universe. ADS-CFT universe means anti-de Sitter universe. When I first saw it, I saw anti-de Sitter. It's probably like a strange, I don't know, 15th century word or something, but no, it's someone's name. It's just, you just add, there's de Sitter space and there's anti-de Sitter space. It's a name, there's nothing to it. So it's like the universe in negative cosmological constant, and we were doing some calculations on it. And he is going very fast because he needs to finish 100 pages of lecture notes that are very controversial when you think about it. There's no lecture like it in 4 days. So he's like Barry Allen, the fastest man alive. So we were making entropy calculations, and he were introducing lots of terminology, and he was saying that I can't get to it and stuff. So let's come to my question. So I'm trying to get